Hi, this is Leetcode question, cycle length queries in a tree. This is the last question of weekly contest 324. You are given an integer n. There is a complete binary tree with 2 to the power n minus 1 nodes. The root of that tree is the node with the value 1, and every node with the value val in the range 1 to 2 to the power n minus 1 minus 1 has two children, where the left node has the value 2 multiplied by val, the right node has value 2 multiplied by val plus 1. You are also given a 2D integer array queries of length m, where queries of I equal ai, bi. For each query, solve the following problem. Add an edge between the nodes with values ai and bi. Find the length of the cycle in the graph. Remove the added edge between nodes with the values ai and bi. Note that a cycle is the path that starts and ends at the same node, and each node in the path is visited only once. The length of the cycle is the number of edges visited in the cycle. There could be multiple edges between two nodes in the tree after adding the edge of the query. Return an array answer of length m, where answer of I is the answer to the ith query. Here are the constraints of the question. N is less than or equal 30, m is less than or equal 10 to the power 5. So here we have this tree, and this is completed tree. N equal 4, and that means that the number of nodes equal 2 to the power 4 minus 1 is equal 15. And as you can see here, we have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 nodes. The root node is 1, and the node in the left always equal 2 multiplied by the parent value, in this case 1, so 2. So the left node value is 2, the right node value is 2 multiplied by the value of the parent plus 1, which is 3. So the right of 3 is 1. Let's take another node, which is 3. The left node of 3 is 2 multiplied by 3 equal 6. So this is the left. The right is 2 multiplied by 3 plus 1 equal 7. So this is this node is the right of 3. Now the question is, we are given a queries, and for every query we need to add an edge between the two nodes. So here the first query we have 5 and 3, so we need to add an edge between 5 and 3. Then there will be a cycle here, and we need to return the length of the cycle. In this case, this is the cycle. So the length of the cycle is the number of edges, which is 1 2 3 4. So we have 4 edges. Also it's the same as the number of nodes in this cycle, which is 1 2 3 4. So the answer of the first query is 4. Then we need to reset the tree by disconnecting this added edge, and move to the next query, which is 4 7. So we need to add an edge between 4 and 7 and calculate the cycle length. In this case, the cycle will be we start at 4, then we go to 7. So this is one edge, then we go to 3 2 edges, then we go to 1 3 edges, then go to 2, 4 edges, then we return back to 4, so we have 5 edges, or it's also 5 nodes. We have 4, 1, 2, 3, 4, 5 nodes, so the answer will be 5 for the second query. And for this query 2, 3, we need to add an edge, and our loop will be this loop, which has length 3. Then we have this query 11, 8, so this is 11 and this is 8, and the length of this of the cycle is, if we start from here, this is one edge, then 2, 3, 4, 5, so the answer is 5. And for the last query A2, we need to add this edge between 8 and 2, and the cycle will be 1, 2, then return back to the node 3. So we have 3 nodes and 3 edges, so the answer is 3. So how can we solve this problem? The idea is, let's take this query, for example 8, 11. So what we need to do is to calculate the number of edges in this cycle. Also we can do is, if we know the height of this the parent, so this node 2 is the first parent, or the first common parent between the node 8 and 11. So if we know L1, which is the distance from 2 to node 8, 2 is the common parent, the first one, because here we have also 1, but while calculating the cycle you cannot go to 1 and return back to 2, because every node in the cycle should be visited only 1. This is why we have to do the first common parent, which is 2. So we calculate L1, then we calculate L2. So L1 is the number of nodes in this from the between the parent, or the first common parent, to the first node, and equal 1, 2, 3. And if we calculate L2, which is the distance or the number of nodes between the first common parent and the second node, which is 11, the second node in the query, so L2 equal 1, 2, 3. So the cycle, the number of nodes in the cycle equal L1 plus L2 minus 1. Minus 1 because 2 is included twice in both L1 and L2. So L1 equal 3 plus 3 minus 1. The result will be 5, as you can see here. And in order to find the first common parent between the two nodes, what we need to do is we need to have to calculate a vector of the nodes from the current node. So the first node in the query, let's take the query 8, 11, and the answer will be 5. So first of all we need to calculate parent 1, which is the parents, all the parents of in the path from 8 up to 1, and we do this by iterating over So if we started from 8, we need to divide by 2 to know the parent of 8. So for every iteration, we can calculate the parent of the node by divide by 2. For example, 8 divided by 2, 4. So 4 is the parent of 8, and 9 divided by 2 is 4. So 4 also is the parent of 9. So parent 1 will store all the nodes from the first node, which is 8, up to the parent. So 8 divided by 2 is 4, which is the parent of 8. The parent of 4 is 4 divided by 2, which is 2, this one. Now 2 divided by 2 equal 1, which is this node, the parent of 2. Now we have all these nodes up to the parent, and this to calculate this vector, it's log of the value of the node. Now we need to do the same for the other node in the query, which is 11. So we have another vector, parent 2, and the first node is our node, which is 11. Then 11 divided by 2, this is 11 divided by 2 equal 5, which is the parent of 11. 5 divided by 2 equal 2, which is the parent of 5. And 2 divided by 2 equal 1, which is the parent. And we need to find 2, which is the first common parent between the nodes in the query 8 and 11. And to do that, we will iterate over the first vector, which is parent 1, and for every node we need to check if it exists in the other vector. So we'll go from bottom to up, and the first node exists on the other parent or the other vector. It will be the first common parent between the two nodes, and while doing that we will be able to calculate the length from the parents or the common parents to our node. So let's say we have L1 equal 1, L2 equal 0. So L1 equal 1, this side L1, because we start with this node, so we have one node initially. So does 8 exist on this vector? No. So we move to the second node, or the second parent, which is 4, and we increase L1. So this one become 2, which means that we have 2 nodes. Now we need to check if 4 is in the this vector, the parent 2. 4 is not in the other vector, so we need to increase this L1 to 3 and move to the other parent, the next parent. So we are moving from bottom to up. 2 to exist on the vector, the other vector, and we stop our iteration, and we know that the length, our L1 equal 3, which is 3 nodes. Now we need to know this L2, and to do that, so we have parent 2 vector 11, 5, 2, 1. and we know this is sorted in a way, so this is the bottom, then we move up and up until we reach the 2, and by doing search, we know the index of 2, let's say is equal to, and so our L2 will be the index of 2 in this array plus 1, so L2 equal 2 plus 1 equal 3. So now we know L2, we know L1, and we know this this is the common parent. So our final answer for the query is L1 plus L2 minus 1 equal 3 plus 3 minus 1 equal 5, which is our answer for the query. Let's look into the code implementation. So we need to loop over all the query to find the answer. The answer is a vector of the same length of the query size, and here we have the two numbers, num1 of the first, or for every query we have num1 and num2, which are the nodes that we need to add an edge between them. Then we need to calculate the two vectors, parent 1 and parent 2. So we start by this number 1, we divide it in every iteration until we reach the root, the value 1, and while doing that we push it to parents 1, and we do the same for the other number. Then we need to calculate L1 and L2. So we loop over every element in the first vector, and we check if it exists on the other vector, and if it exists we can know the distance from the index 0, or we can know the index of that element in the second parent, and so L2 will be that index plus 1, and our final answer will be L1 plus L2 minus 1.